Cool. So, um, hello everyone. My name's Chris, and I've come to talk about GNU Geeks. Now, I wasn't particularly planning to do a talk on this, so and the slides I tweaked haven't worked because my laptop doesn't connect. But so these are slides which I presented back at FOSDEM, but hopefully it's still mostly applicable. So, who hasn't heard of Geeks? Cool. One. So two people, three maybe. Okay, cool. So who hasn't? So who's heard of it but hasn't used it? No one. Okay, one person. So everyone else has used Geeks. Cool. On and off. Okay, cool. Well, so Geeks, it's a GNU project, so GNU Geeks, or Geeks for short. It's something that's a bit hard to describe because it's a few things in combination. So it's definitely a package manager. It's also a distribution of the GNU system, so you can install it as an operating system, and some other things as well. So it can be hard to describe what Geeks means, what it kind of brings to the space of package managers and operating systems. So three important characteristics I think that it has is dependability, it's dependable, flexibility, and being a general purpose package manager. So when you're using Geeks, you kind of put the state is managed in a mutable store. So this provides a rock solid base to build your system upon. And package behavior is fixed at build time because of this immutability. Because things are immutable, this also gives you unique ability to roll back. You just switch back to the previous state. Also, if you have any questions or comments, just shout them out, and while I'm speaking, I'll repeat them for the microphone if I remember. So, any questions so far? No? Cool. So, flexibility. So, Geeks, you have the option of using pre-built packages. So you can fetch packages from a build server or build servers on the internet, but you can also build packages from source. You can tweak package definitions and add your own. And because of the way the store works and mutability, there's no conflict between different versions of packages, within the store at least. It's also a general purpose package manager. So it includes a whole variety of software written in different languages for different purposes, multiple bits of software that do similar things, all of that. It's also suitable and used in multiple different applications. So everything from like running on a computer or just using as a package manager on another system, or building virtual machine images or deployed on a cluster of machines. Yeah, lots of things. Mm-hmm.
So the platform before, box solid base and individual box solid base, like Debian has a package manager server and a package store. So what's the very big difference between Debian and Guix in terms of packages, which are somewhere stored and can pull them down?
So the question I think is, what's the difference between Debian and Guix? Where, yeah, so Debian, is this about how it installs packages on the system, or how packages are kind of downloaded?
What's the difference?
Both. Okay. So in Debian, a package is kind of a combination of a bunch of files that are put kind of across the root file system, as well as some scripts that manage the kind of life cycle of the package. So scripts that may run when it's installed, when it's removed, when you configure it, that kind of thing. In Guix, the state for a package is really just the store item, the single like directory in the store, and its contents. So the store is always at /gnu/store. Then you have a hash and a package and the package name and version. So when you install a package in Debian, you have to be root because you have to modify the root file system in multiple places. When you install a package of Guix, you can be, well, you don't have to be root because what you do is you basically ask the daemon process that manages the store to please do some things and make these store items appear. And because that, like each user in each part of the system and service can have its own view on what it is looking at in the store, that normally doesn't affect any other bits of the system. So it's not something that has to be restricted. So yeah, does that make, there are quite a few differences in quite a few ways.
So now, what I know before, that you can have a local user-specific Guix installation.
Mm-hmm.
But I didn't understand the difference at the back server side, back server side. That, like, for me as a user or super user, whatever, I say, okay, install this package, and then he magically like this to install. So Debian is always root, and Guix is root and non-root. But on the server side, on the package repository, whatever it's called, store, is there a difference?
So yes. So
What the difference means for me as like what I can see as difference.
yeah. So I think the question is, so taking Debian and Guix as examples, what the difference is from the perspective of serving or providing or package repositories, that kind of thing. So as I understand it, the tooling around Debian, things like apt, that's one of the tools to access a repository of packages. It will, you say, kind of apt update, and it will fetch the kind of manifest, the list of available packages and versions. And these are binary packages, so packages that have been built somehow and they're on that server. And so then, like, those are the ones you have available, and you can say ask apt to install one, and it will go and download that file and then pass it off to dpackage, which is a tool for actually unpacking it and installing it. So in the case of Guix, when you ask it to install a package, Guix on your machine is first going to try and work out what that means. So it's going to kind of compute the derivation for the package, so the lower level representation of the recipe to build that package in a way. And then once it's got that, it will look if any of the term often used is substitute servers, because the binary packages in Guix are meant to be kind of substitutes. They're a substitute for building it yourself. So we'll look if any of the substitute servers that it knows about has a substitute for the thing or things that it's trying to install. And if it does, and if that's one that you've told Guix to trust, is we'll go ahead and download that rather than building it. So for Guix, you have the package recipes on your machine, and you do some operations there first before you even start talking to the substitute server online. Whereas in Debian's case, the list of packages you get from the remote server. I mean, often this manifests in that, like for Debian, the packages are kind of exactly what you see on the remote server, whereas with Guix, the packages are what the recipes you've got locally define, and that may not match up with what's on the remote server. Does that make any sense?
Okay, I understand maybe the difference, but what's the advantage for me as a user? I type in install this package in Debian, I type in install this package in Guix.
Mm-hmm.
So what's the different advantage for me?
So I'm not. Well, advantage depends on what you're trying to do, I guess. One way I see this differ is that, or one disadvantage I often see with using Guix is people, they might do Guix install LibreOffice, and Guix goes, there's no substitute available for this particular LibreOffice I'm trying to install. I'm going to start building it. And what you may want to do as a user is just please get me a substitute for LibreOffice. I don't really mind what exact LibreOffice I want. Just something that I don't have to build from source. That is more difficult because you have to work out, okay, what recipes correspond to substitutes that are available, and go and install one of those. Whereas with Debian, the packages that you have available to install are exactly that, which are available from the remote server. However, to spin it around the other way, when you install something with Guix, you're providing the substitute server is honest and it's actually serving you something that is a substitute. You should get something that's exactly what you specified, so it's been built exactly in the way that the build instructions on your local machine have defined, if that makes sense. Yeah. I mean, so one of the there should be, because of the architecture Guix has, it should be possible to do some quite cool things with substitutes. For example, because the signatures are kind of separate from the substitute, you should be able to fetch substitutes from machines you don't trust, which are the content matches a machine that you do trust, for example. So maybe you'd be able to fetch substitutes from other machines in your network if they're available or something like that. That's still a thing in the pipeline, but maybe in the future. Cool. So I've covered now dependability, flexibility, and the fact that Guix is a general purpose package manager. Does anyone have any questions on any of those things before we continue on? Or any questions at all at this point? Cool. Let's crack on then. So this command is an example of how you might install a package. So you can say Guix package -- install hello. There's actually a shortcut now. These slides are a little old, but you can actually say Guix install hello now. And that will give you hello. This, however, might do something quite different to what you might expect if you've come from another package manager, because this actually acts on, by default, your user's profile. So this is installing hello for you, but not necessarily hello for, not necessarily making it available to anyone else who's using the same system. So the way that works is, in your home directory, you have a .geeks-profile symlink. That symlink points to a file in /var/geeks, which is also a symlink, and that symlink points to the generation of your profile, which is also a symlink, and that symlink points to a directory in the store. And that directory in the store is actually a directory which contains some symlinks. And those symlinks point to the packages or the files that profile kind of contains. So, yeah. In this example, if you look from it, if you take the bow tie 2 right at the bottom of the diagram, so that is referenced by the profile. So there's a bow tie 2 symlink in the bin directory of the profile, which links to it. Then that profile is your current profile because it's kind of, through the symlinks, pointed to by the .geeks-profile symlink. And the way this works is you add, say, .geeks-profile/bin to your path, and then by magic, you've got bow tie 2 on your path for all this kind of indirection. Does that kind of make sense? Yeah. So the reason there's this much indirection is it allows you to do some cool things. So when you remove a package from a profile, so here we're doing Guix package -r bow tie, what actually happens is the store is immutable, so you can't change the store. So you generate a new profile without the bow tie package. So here at the bottom, we've got a new entry in the store, this new profile, which just includes SAM tools. And then if you want to roll back, all that requires is changing a single symlink to point to the previous generation of the profile, and then everything is as it was before. Yeah. Any questions about that?
You speak about the packages installed in the isolated environment for each project. What about the libraries which are common, shared libraries for each project?
So the question is, packages are installed in an isolated environment. What about shared libraries? So Guix does use shared libraries like dynamic linking, but the way it does that is you dynamically link against the kind of full file name for a library. So you don't link against like glibc, you link against GNU/store/hash dash glibc/lib/blah. So there is no user lib on a system that's running, or if you're using Guix as a system, you don't have a user lib. I mean, if you're using Guix on a system with a user lib, that's normally not being used. All the software managed through Guix is using the libraries in various places in the store. Does that make sense?
Yeah. What about, let's say, user installs the package, it's a LibreOffice, and then another user wants to install the same package. So, will the binary be shared across the two users?
Yeah. So because like installing something is just to kind of make this appear in the store, and then I'll use it in my profile. If the first user says, okay, I want this particular LibreOffice in the store, and adds to their profile, and then another user goes, okay, I want this particular LibreOffice in the store, so I can use it in my profile. It'll just be in the store once, and you won't have to like fetch it or build it the second time. And if it's then removed from the profile, exactly what happens here will happen. The user who removes it, they just generate a new generation of their profile without that package. And Guix includes a garbage collector to remove items from the store when they're no longer being used, which is useful when you've got old bits of software, if that makes sense. Any other questions? Cool. So you've got like a per user profiles, but you can also create kind of ad hoc profiles, kind of ephemeral profiles. So the Guix environment command is a way to do this. So if you ran this command, what you get is a new shell. So it creates a subshell. And within that new shell, it'll have loaded an environment which contains all the packages that you need to build Hello. So things like a compiler. So if you run this command and then look up where GCC is, you'll see that it's in this profile that's kind of been added to the shell environment. You can also get Guix to give you kind of a profile with some ad hoc packages. Just please give me a profile with the Hello and Guile packages in it. Does that make sense? So this is an example of what such a profile would look like. So in the bin directory inside the profile, you have this is a union directory in a way. So it's a union of the files within the bin directories of the Hello and the Guile packages. So the Hello package includes bin Hello, and the Guile package includes bin Guile plus some other things. So this directory includes the combination of the two represented through symlinks. So you've got symlinks to all of the things in both packages. Cool. So yeah, so you can install, like manage your user profile. You can use the Guix environment command to kind of do more ad hoc profiles, which can be useful. Guix environment also includes some support for Linux containers. So you can say, give me an environment, but I also want it to be in a the shell in that environment. Please put it in some different namespaces. So in particular, it's in a different mount namespace, which only has visible some kind of system locations and the current working directory and the set of things within the store which are necessary for that profile. So if you ask for an ad hoc environment running in a container for the hello package, then what you get is quite a minimal kind of environment. It only has, well, what's that when I ran it? 10 items in the store visible. The reason I'm using echo here is because you don't have core utils, so there's no ls on your path, so you have to use echo. Does that make sense? Any questions?
So this environment is active as long. How do you get out of it then?
So the environment, all it is a shell process, bash.
So you exit and it goes away.
Yeah.
Okay.
The profile will remain in the store and just be garbage collected next time. It's like, yeah. But yeah, the container is just the process running in those particular namespaces with the environment variables set such that it's using the right things. Yeah. Guix also includes a whole load of tooling for doing like working with Guix packages and other bits. So there's a Guix graph command, which allows you to give it a package, and it will generate you a graph in the dot format. Here I've converted to a PNG, I think. And that will display the relationship between packages. So here you can see that hello references some parts of the GCC lib and glibc, which references bash. Does that make sense? And the way this works, and this comes back to your question about dynamic linking, is if you look at the shared libraries which hello links against, then you'll see the full kind of absolute path to the shared libraries. And this, if you imagine, like on one side of the spectrum, you've got static linking, where you get kind of absolute certainty about the behavior of the binary because the libraries can't change. And dynamic linking, where you link against something that's changeable, like a library in /userlib. In a way, this approach where you link against something in the store gives you a combination. Well, I think it's a combination of the kind of best of both worlds. You get in a smaller binary because it doesn't include a whole copy of the libraries, but you also get a lot of reliability because given the store is immutable, it's not going to change. Does that make sense?
Yeah. This is okay with the library as small as hello, which has very few links. But what about the more usable packages? The shared libraries may be too more complex.
I think it works the same. I'm no expert on C or dynamic linking, but I think it just.
glibc and glibc is okay
Mhm.
because they have a static path, mostly the stable path. But the shared libraries which are maybe changed as often and the versions are different for different packages might be complex in that case.
Well, I mean, the linking is just done against the absolute path. So I'm not sure what do you.
So maybe that garbage collector or some human methods are trying to figure out which is the latest and stable shared library, shared path, and try to link it. I'm not sure. Just guessing.
Um, well, everything is decided at build time. So um, when you build the package, you link against the libraries that are available, and you use the full path, and then you'll just always use that at runtime. It's kind of one of those. It's a principle in that you want the behavior of the package to be fixed, so you don't want it to change. And then there are some ways of kind of compromising on that where you want to compromise on that, but by default, things are normally very static in behavior. That makes sense.
So if one user installs a package and one user installs a package a year later, these are different packages, different binaries, because they are linked to different libraries, but they won't change. So these users are stuck with the binaries that were installed and the package was installed.
Okay, so I think the question is about what exactly is installed when you install something, maybe.
Okay.
Um,
Complicated. Somebody installs like hello,
yeah.
and a year later somebody installs hello, another user installs hello. So these are different hellos because at the time of installing, different libraries have been linked to
Mm-hmm.
that. Different libraries have to be installed. So, and the older installation uses the older library type and is stuck with this. That's the idea. That does change.
Yeah.
So, and he can change if he does run an update or whatever. Whereas if the older user wants to have the newest version, how does he do it?
So
Upgrade or whatever.
yeah, I think the question is about updating packages. So in exactly the same way as you just change your profile, you would, I guess, if you imagine this is rather than removing a package, you install a package or update a package. You would. So the first thing is you update your package definitions. So you use a newer version of Guix, a newer version of the package recipe for hello, and then you install that, and that will be built against the newer shared libraries. So it's all about the package definitions and the version of Guix which you're using. That dictates what package you get, what output you get. And the hash in the, so if you have a look at the first line here, it says /gnu/store, then the hash, and then dash package name. So the hash dictates the kind of entire recipe for building that package and all of its dependencies as well, going all the way down the tree. So if you change any of that, if you use a newer version of glibc or use a newer version of hello, you'll get a different hash, and that will be, if you upgrade to that, then that will be what you're using, if that makes sense.
I think I got it.
Cool. You can also install packages in, so you have a default user profile, but you can also create arbitrary profiles, and they're represented in a very similar way. You have a symlink that links to the generation of the profile, and then that generation link, so test profile -1 -link here, will link to the directory in the store. There's some software which Guix can interoperate with, so direnv is one bit of software. So you can, in your .env file, you can set out to use Guix to tweak the environment, which is useful because direnv hooks into your shell, so you can cd into a directory and direnv will invoke Guix to make some changes to the environment. Guix Pack is also a really cool tool. So you can say Guix pack and then some packages, so Guile, Emacs, Geyser, and that will generate you a tarball containing those things and all of their dependencies. So you can copy this onto a different system, unpack it, and run them, hopefully. You can also use Guix pack to generate different kinds of artifacts. So it has support for Docker containers or OSI container images. So here you're generating something that you could pass to Docker or some other tool that would result in a container image containing these packages. Yeah, Guix also includes some tooling for writing package definitions. So there is a set of importers. So these can use metadata that can be found on things like the GNU website or the PyPI package directory, cpan, hackage, stackage, crate, as Ian was talking about yesterday. And these help you to write a package definition. As an example, this is a package definition. It's set out as a scheme record. So you define a variable called hello. That's the defined public hello bit. And then package begins the record. It has a number of fields, so name, version, source, build system, synopsis, description, homepage, and license. Here, there aren't any inputs. All the kind of build process is encapsulated in the build system. Are there any questions about this? Cool. All right. So, I mean, this package definition may look quite innocuous, quite small, but this is what it kind of represents. So this is a reasonably complete graph, and it's actually not a particularly complete graph. It's not showing the build system's interaction on here, but this is I think the graph of derivations for the hello package, and it, of course, you can't read any of the text. Definitely can't read any of the text. In fact, you can only just about see the colors. But if you look around the edge, the text is in black. These are the kind of fixed inputs. So things like source packages, things like patches, things like the bootstrap binaries. So the Guix package definitions will include the hashes for these bits. So if you have a look where the package definition says SHA-256 base 32 and then the hash, this is the hash of the hello source code. So that will be one node on this graph, the hello source code. And then as you get towards the middle of the graph, the pink color is what I've colored the derivations in. So a derivation here is combining one or more kind of fixed outputs with maybe some derivations as well to generate something or some things in the store. So I forget what's in different places in this graph, but somewhere in there will be one box, which is the actual hello package, and everything else is all the bits, intermediate bits that go into producing it. But this is all kind of what you get from this package definition, plus all the implicit things that go into it. Any questions on that? Cool. So I was going to say some other stuff at the start, but I couldn't get the updated slides to work, so to run through that. I think there was a talk given at the last GNU Hackers meeting, so a couple of years ago. At that point, like Guix had around 6,000 packages and a reasonable set of like system bits, so services, encrypted root support, a GNOME desktop environment. But at that point, there'd been no kind of 1.0 release. That happened earlier this year, back in May. So there was the kind of big Guix 1.0 release. At that point, there were nearly 10,000 packages within Guix. You could do ISO installation images, which you hadn't been able to do before. There was a text mode installer, which is quite neat, and some user interface improvements and other bits. Now, since that release this year, there was a small patch release, and also there's been some more packages. There are now over 10,000 packages, which is quite a nice number. And things are changing all the time. If you are interested in anything that's going on, there is a blog on the Guix website, which includes posts about interesting things. I think the most recent post was about a Guix deploy tool. So this is kind of a tool which you run on your machine to kind of affect the state of a remote machine. So you can deploy the state of some machine in a way. I haven't used it, but it was the project from a Google Summer of Code student this year, which was quite successful. And there's a blog post about that up on the blog. There's also a blog post about using LZIP for substitutes, which happened reasonably recently. And also using the Software Heritage Archive as a source for release tables and software. And relating to Ian's talk yesterday about Rust, there's a talk about bootstrapping Rust in Guix, which came up as a question. I think Guix builds mRustC, which is a Rust compiler written in C, and then uses that to build a very old version of Rust, and then kind of ratchets up. So it builds a slightly newer Rust, and then uses that Rust to build a slightly newer Rust. And I think after about 7 or 8 steps, you get to the current version of Rust. But yeah, there's a blog post about that as well. Cool. So yeah, I hopefully, if you didn't know about Guix before, this might have filled in a few gaps, maybe made you interested in it. It's quite easy to try because you can install it on most GNU/Linux systems. In addition to the package managers you've got on there. Yeah, any final questions? Cool, yeah. Yeah. I'm going to swap the microphones.
Better. I don't know if this question was already asked, but what kernel does it use? Does it use GNU Herd or Linux or both? Or?
So by default you're using Linux, but it's the Linux Libre release of Linux. But you have control over this. You can just when you're defining your operating system, you pass in the package for the kernel. There has been some work getting Guix ported to the Herd. At the moment, I think the stage of that is just trying to get Guix reliably working as a package manager on a Herd system. So often the Debian GNU Herd. Because I think there's been some problems like getting the packages to work reliably. Hopefully once that is in place, it might be possible to get an actual booting system where you can get Guix with the Herd. I think there has been some work on this, but I don't think it's been achieved yet. Does that make sense?
And what boot system does it use? Systemd? Or?
So the boot system is also configurable. So by default you're using grub, but there has been some work on, I think at least U-boot is supported as well, which is used on some ARM devices. And I think there's maybe other boot systems supported as well, or at least now that 2 have been supported, it should be easy to add support for others.
Thank you.
Any other question?
Cool. So I'll be around for the rest of the event, so you can come up and talk to me or other people about Guix as well. I also made some stickers for I think FOSDEM a few years ago, and I've still got lots of stickers. So if you want any stickers that look like that, so there are big ones and little ones, There's also some stickers which I got from Julian, who's another person who does some geek stuff. They're like that. I also got some reference cards, apparently lots of reference cards that I printed off a while ago. So I think they're still relatively up to date. But yeah, so I'll leave them on the desk over there perhaps if you want to come and get stickers or reference cards. Cool.
Thank you very much.